Hello everyone, this is a bit of an experimental video. So over the last week I have been soldering up a bunch of tricorder boards and I thought why not do one as a video. So I've saved this one back and I wanted to get going. I have got 3 cameras running: my old phone, my new phone, I say new, it's about 2 years old now, and my new digital microscope. The microscope is running on Fmpeg and it's not terribly amazing quality, but I hope it will do, and I'll make sure that's all sharp as well. Yeah, that's close enough. And I am recording my sound on the laptop. I also have KiCad running on the laptop as reference, just so I can double check stuff on the board. Now, like I said, this is a bit of an experimental video, so if you like this, let me know. If you don't, let me know, and I won't waste anyone's time with it again in the future. To say again, as I've mentioned before, I do have a bit of a stutter and it may come up occasionally when I do this. This is going to be a fairly long video and I may have to end up rambling a bit because, well, there's only so much stuff I can talk about. I will talk about the components as I put them down, but yeah, that's so much. The other thing to be as aware as well, I may do a few little cuts here and there. That's mostly so I can go and take a break, because this is going to take a while. But also, just to speed things along a little bit, you don't need to be seeing the same thing happening over and over and over. And if there's, like, I'm searching for a component, you don't want to be waiting like a minute or two as I'm going through boxes, just in case I've misplaced stuff, which there is a good chance. As I do this, you will see mistakes, you will see bridges. I will be trying to repair them as I go, and if things get really bad, well, that'll be a first one. These have actually gone really smoothly as I've done it, but mistakes may happen and I will repair them as I go. Right, I guess really it's time to get started. I am going to turn on my hot air gun, turn on the... turn on my soldering iron, and where's my tinner? Let's get that freshly tinned as well. I'm also a little bit running low on my solder paste, but if that runs out, I've got some spare just in case. Though that's been sitting in my drawer for a while, I have no idea if it's dried out or not. It will be an exciting adventure. Right, let's get started with this one. Like I said, it's going to be a bit of a ramble on occasion. There's only so much I can talk about. Sadly, I can't put any music on because, well, you know, copyright and YouTube. But, yeah. Right, this is one of the 2 capacitive sense buttons that are on the tricorder. This one's on the door section. And ooh, that's actually a bit cooler than I thought. And that's too much. Anyway, I'll do. I'm going to have to sort something out with that box because that's awkward. Let's try that again. I've only just set everything up and obviously things are not really organised as well as it probably could be. Right. Capacitive touch. I believe that's in my parts bin up here. That's the FT cap touch. There we go. Right, that's going on. As people that are a little bit more electronically inclined may ask, why am I using a capacitive touch IC rather than just using the capacitive touch that's built into the microprocessor that I'm using? Well, there's 2 reasons. One, when I originally came up with the capacitive touch idea, that's back when the original tricorder was running on the Arduino-based 18 Mega 328 chip, and that didn't have capacitive touch, so when researching, I found this chip. I'm now using STM32F103s both in the door PCB, which is this bit here, and on the main body as well. To be honest, I mean, I need to double check, but I think there may actually be enough GPIO now on the door to use for capacitive touch. So if indeed this if I want to try and save some of these chips in the future, I can do that. I'll have to do a bit more research into it because I don't know if it needs any extra circuitry or not, but yeah. This has taken a bit of a while to heat up. I wonder if I need to turn this up a little bit. It's at 255 at the moment, which, to be honest, usually was enough, but let's go up a little bit. I didn't want to melt some of the softer plastic parts and when I was working on the other section, so I'll go with this for now and see if this heats up a bit better. Come on. There we go. And the thing is, though, it may be worth doing in the future, going back onto the STM32s for the capacitive touch. The problem is, well, there's two things, a bit of an issue actually. The STM32 on the main board, that is fully populated. Every single IO on that is actually used. I think there may be maybe one left, but it's all pretty much used up. So that's not really something I can do there. But the other issue is the original manufacturer of these chips, and that's a bit of dust that's just blown onto that. Let's get rid of that. I've got the window open as well, and you might be able to hear some of the wind. The other issue as well is this chip is no longer manufactured, or at least not by NXP, who are the original designers. I believe another company has taken over. Has taken up the IP and are manufacturing them, but they are harder to find. I mean, I did get enough to do all my builds for the time being. Well, I've got more than enough really, but there's always a bit of a risk trying to use stuff that is not entirely obsolete, but maybe harder to find. But to be honest, the last couple of years, everything's been hard to find. Again, if you're electrically inclined or heck just PC inclined, you know about the parts shortage. It's not just PC parts that have run short. Microprocessors, the STM32 that I use, it's next to impossible to find in any official store. And if any official stores are posting them, I mean, the most official one would be, I think it's LCSC or LSCS, I can never remember. They charge quite a lot. I mean, I can't remember exactly off the top of my head, but I think I saw it going for like 10 quid a chip or something. I mean, it was stupid. Whatever it was stupid. You're just not going to do that. I mean, I've always bought the chips off AliExpress, which has its own risks, and you've probably seen my other videos. I've been burned. I've had fake chips, or not just fake chips, broken chips, or relasered chips. So it might be another STM32. So the basic checking of it might show up, but it might be something like a different. It might be like a different part of the family, like a lower spec one. So, for instance, on the door here, I've got an STM32F103C6. So the C6 has got less flash than the CB or the C8. Not flash, sorry. Flash. So less program flash. It's only got like 32 kilobytes. And you often get them rebadged as CBs or C8s, which obviously is no good if your program is nearly 128 kilobits. Oh, I've just gone over the zero mark on that one. Where is that? Let's have a look on my screen. Okay, it's that side. So yeah, I got burnt with them a few times, and buying off AliExpress, while they are, they're generally cheap, and it's always in the past been a safe bet. Well, at least for me anyway. I know other people have been burnt with loads of different type of things there, but these ones, I've been kind of lucky. I've had plenty come through that have been fine. I've had a couple of orders that weren't good, but I managed to get a bunch of chips for I bought about 30 chips like earlier in the year, and I was lucky. They were reasonably priced. They weren't like anywhere near what they used to be. They're still like 2 or 3 times the normal price. But I managed to get them just before they raised the price as well, actually. But hopefully that'll last me until the chip shortage has sorted itself out. I mean, I've heard STM32 are currently only making chips directly to order to the automotive industry at the moment. They're not really giving anything to suppliers. I don't know how true that is, but as of like in the recent months, it's still pretty impossible to find the chips in a normal supplier, which is not great. Eventually, I will run out of these chips. I've been pretty good, and I've been recycling some chips from older projects, but is that on? That's been a bit awkward again. I think because my window's open, it's not as warm as it has been. I think it's cooling down the solder a bit better because I've got a decent breeze here because I haven't got fume extraction, so the breeze is my fume extraction at the moment. That looks okay. Could be better. You know what? I'm going to... let's see if I can do this while I'm still recording. No, I can't do it while I'm still recording. Okay. Hopefully that's not too dark because I have been having problems with this this microscope. I like the microscope for its use, but its recording in camera is not the best. Exposure controls are a bit buggy if they work at all, which, trust me, they haven't always worked. And the like I said before, it's running on Motion JPEG, so it's noisy and the files are large. Oh, again, that's what I was going to say. I may also have to pause halfway, in case I run out of time. I did warn you this was going to be a rambling video. I think that's okay. Let's get that line a little bit closer. Actually, you know what? I'm going to stop this recording on here for the moment. Right. I'm going to go into the settings. Let's drop this exposure back up to 0. Which makes absolutely no difference. Like I said, it's buggy. But as we go into the camera mode, I can change the exposure here, and it changes it as well for the video, which again, hey, let's... Oh, that's wrong. Oh, there we go, that's a bit better. Okay, back into video mode. No, I don't want to watch a video. Okay, alright, back into video mode. That's turned up and record. Right, okay, that's back in recording then. Yeah, like I said, the exposure on this thing's a bit buggy. You change it and it doesn't change, or you change it and it changes to the next value along the list that you've not set it to for some reason. looks okay. I'll double check that in a second. So as you've noticed, I'm not using any masks or anything. I'm just blobbing on the solder, and I'm getting it roughly soldered on with the hot air gun, and then just drag soldering with some with the iron, which usually works. Just yeah, that looks like it's not gone on. That might again not be on. It's gonna have to do that again, I think. Jesus, that's terrible. Right. I think that went on okay. There was one on this side as well, wasn't there? Does that look any better? Are you kidding me? Oh, that's better. I won't deny I'm missing the music a little bit at the moment. Been listening to Yes a lot this week. I haven't actually listened to their music for a few years, so it's just nice to hear again. But they're the newest, well, I say newer stuff, the 90s and 80s stuff rather than the more psychedelic earlier stuff. Don't get me wrong, I really love Roundabout. It's a brilliant album, but I think lately I've been very much into sort of like retro wave and sort of like old American rock. I say old American rock, American styled rock, and the album is very much that. I mean, Yes are not an American band at all. Are there any American members? There's one South African member, I know that much, but most of them are English. That's still not on. It's terrible. This one's been really awkward today. I don't know why. This one's so easy last time. I mean, it looks like that's soldering, but it's not really attaching to the pins. It's looking better at least. Let's take some of that off. No, still not. What the hell is wrong with this chip? Is it corroded? There's only so many times I can do the drag solder on this. I mean, these are sealed chips. They're not like it's not like it's dodgily ordered. I believe I ordered these ones directly from the newest supply, which I still can't remember the name of the new company. Oh, there you go. They're on now. Okay, good. Right. Let's clean that again. So, like I said, this is the second, or technically the first, capacitive touch button controller. This basically just gets directly wired to all the pins that end up becoming soldered to tape. So, for instance, on the door, you've got these little sections here. Where I'm going to run tape through the front of the tricorder down onto the back and just solder them directly onto these pins, and they're wired directly onto the chips. So there's another set for this front section, which is this bit, and it's going to connect through this ribbon cable up to this connection, up to this connector, and then onto the chip. Right, that one's done. Let's get the one that's next to it ish. That's the JQ8400 audio chip. That's an awkward one as well. I mean, the chip's fine. And securing them seems to be okay, but it's very much what I consider a legacy part from the old tricorder, because I used the is it DF Robot audio module for it back then. Oh, let's not move that around. And that was the I used a lot of modules in the first version to test with, and that's how I ended up finding components that I could trust. And that's kind of hung over. I mean, obviously, normally that'd be a good thing. It doesn't. If it's not broke, don't fix it. But the problem with this audio chip now, it works, but it does have a few limited features, and I'll probably go over them in a minute if I can remember what they are after I've actually found it in my parts bin. Which, where is it? I'm sure I've got it called audio modules or something. Sound module, there we go. Stop doing silly things like knocking the camera. There you go. I found the audio module box, but I can't find the chips. I mean, that's one chip and it's floating around. That's probably fine. Probably got them in my other box. I've got a big box in front of my soldering area, which has got the majority of the components for the tricorders in it. Yeah, anyway, this chip's probably fine. It was loose in the box. I'm not really sure why. Maybe it got out of one of its packaging, but yeah, it looks like a fresh chip. Right, so yeah, these chips, they are Chinese, and it's I mean, there's nothing against Chinese at all. That's not what I mean by that. It's just that there's very little documentation. It's very clearly a very limited run of chips that it made. I mean, they probably made millions of them, but in terms of like, typical chip manufacturing, these are not like your normal run-of-the-mill chip. I'm sure they probably made this to go into things like toys and various other little projects. But the documentation's pretty crap. There is a little bit of... There's a Chinese data sheet, which isn't complete. There's an English data sheet, which is a translation from the Chinese data sheet, and it's even more so incomplete. But at least it does have the commands. It has all the commands listed on the sheet. It runs off standard, UART serial. It's not terribly fast or terribly responsive. It's there's a good few milliseconds of delay between sending, send a command and sending. It's only running, I think, like 9600. And the other thing you can't do, you can't queue. You can loop, but you can't queue audio. So once an audio file finishes, you can't tell it to run the next file. So if, let's say, play audio file 1, you can't set up a queued command to say play audio file 2 once 1 is finished or something. Which is a bit annoying because I would have liked to have used this chip for some other projects, but I've got an audio project coming that I want to do, which, to be honest, I'm not entirely sure what it's going to run on yet. It may be a didnt, it may be a ESP, it might be a Pico. I'm not really sure yet. Something that can handle audio directly and ideally high-res audio directly, which would be very nice. Anyway, so this chip, I mean, it's fine for this, but it's not the best audio chip. But also, like I say, I wouldn't say it's not dodgy, but it's definitely not like a very well supported Chinese chip. I mean, you see them around. I know loads of people have used these for different types of projects and whatnot, but that's a really good bridge, isn't it? I don't really want to wick that away because I could use that on some of the other pads. Because that pad's looking a little bit... Oh, come on, be helpful. That's the other thing as well. This looks like it's genuine, let's say genuine mechanic. I'm sure people have heard of mechanic, and I'm not even sure if mechanic is even genuine itself, but my solder is definitely not the best quality. It doesn't wick well, it doesn't flow great. I have to use tons of flux to get it to do anything. And that's saying that these wicks aren't amazing either. I mean, I'll be honest with you, it's leaded solder. I'm not going to pretend it's otherwise because, don't get me wrong, I don't think the industry should move to leaded solder away from the unleaded because the industry actually works with leaded solder. Sorry, unleaded solder. It works for them fine. The issue here is for average Joe electronics guy, unleaded solder could be a pain in the ass to work with. It doesn't flow very well, generally speaking. Quite often needs high temperatures. Even I get some bismuth stuff. In fact, I've got some bismuth stuff on the bismuth or busmuth. I've got some stuff on the way to replace this running out lot. But yeah, that generally doesn't work very well for average Joe. Oh, this is the other thing about this chip. I mean, it's not a fake. It generally is a real chip. But yeah, it's even IPA wipes off some kind of like paint marker that it's got on top of it. I don't know why. Like I said, it is a genuine chip. It just, unless it is a clone of a clone of a clone, I don't know. They work though. That's in the end. That's the main thing. It does still work. I have tested them. But yeah, if I clean this right off. Oh, I just got a message and I didn't want it to give me a message. I told it not to. Alright. So if we clean this right off, you can see that it's still got the original, the JQ engraving there. Let's try that a bit. It's hard to see, but yeah, the original engraving is there. It's not like it's covering up an old, a different engraving. Just for some reason, they've put a black ink on top of it and lasered in the new thing. Maybe these chips are kind of like not an FPGA, but maybe they're like a reprogrammable chip to do other things, and this is just what they're doing this time around. I'm not entirely sure. Like I said, it works, does the job for this. Yeah, it could be better, and I probably, in some future stuff, I may be looking at a different chip. What should I do next? Let's go back over here and get this STM32C6 sorted out, which I believe I've got in here. There we go. Found the C6. Anyway, like I said, the C6s themselves, they have less flash, but that's fine for this because the program that's running on the door is really quite a basic program. It's not doing very much. It's got the my serial library, and all it's really doing is relaying the LED data and the button data, and that's it. It's pretty dumb on its own. It's not doing very much. It's still got FreeRTOS running, which I'm using as a scheduler, but generally speaking, it's not doing very, very much at all. Yeah, where is my 1 pin? So for this, yeah, why waste a more expensive chip with more memory? Kind of cheating this in a way. I haven't got a hot plate, so I'm using my hot air gun just to help this flow out a little bit thinner. It's still a bit way too much on in this one. I've been getting quite good at it, trying to put little amount on, but yeah, never mind. I mean, this is going to bridge that count. I'm going to have to definitely wick a lot away on this one. Oh, I was talking about Yes, wasn't I? Right. Yes, the band. So yeah, they're prog rock. I think started off in the 60s, maybe 70s. My dad is a massive fan of it. And there's been like many old bands. I guess there've been a few iterations of them. I don't know if they're still going on now. I believe the drummer died recently, actually. Oh no, the keyboard player died recently, didn't he? But yeah, they've been going around for a long, long time, and they've come around in a few different guises. I think the band even split into two different bands for a while, both for a while calling themselves Yes, and both having a legal fight between each other. But that got sorted out. And what was that? I heard like two bing bing sounds. I wonder where that came from. Oh no, everything's still recording. Yep, everything's still recording. So no idea what that was. Right. Yeah, the 80s and 90s albums. I was going through them again more recently, or this week mainly. I haven't heard their music for years. I think I first introduced myself to them on their like Yes Union album. And there's something about the American rock sort of style that they got with it. It's still their sort of like progressive rock as well. You know, their normal prog rock stuff, but mixed in with a little bit of American style, sort of like guitar and almost country music, and I quite like it. I mean, it's nice to listen to. I'm normally into a lot of synthwave at the moment, a lot of 80s style of music. I've definitely been a retro fan all my life. I think even in the 90s, when a lot of people were taking the piss out of 80s music for its synthy style, I was still a massive fan of 80s music. I thought things like Depeche Mode were amazing, and anyway, but it's all coming back around again. People liking synthwave a lot these days. Reminds me, I've got to check out Gunship. I haven't checked and see if they've got any new stuff out recently. Right. Come on. So I said the stuff doesn't wick very well at all, but I got it. Right. I'll try and capture everything on the microscope if I can, but occasionally I may have to take it off. The problem is the stand that actually holds all the display. It's kind of in the way a little bit, but oh well. No, that was just a bit of flux reflecting on there. Right. Okay. Just clean that off. I think maybe it's using a new cotton bud. Been having to be really frugal with my cotton buds because I was running out. I still am running out. In fact, I need to buy a new box, but my dad managed to find a few from his workshop area and lending me a few, but I'm still going to be a bit careful and not waste them. So there will be a fair bit of greasy residue still from all the flux. I will be giving these a proper wash at the end. I mean, not at the end of this video so much, but once I'm ready to start putting these inside the tricorder bodies, which they're pretty much ready to do. I'm just waiting for some stainless steel flux to arrive from China, so I can solder the hinges, or solder the bolts that are holding the hinges correctly. I could make that better. So yeah, I will be using cotton buds a few turns over just to save them a bit, dislodge most of the fluxy grease, heat that up a bit, and then just use some IPA to flush it out after heating everything up. So as the IPA basically boils off under the heat, it helps push all the trapped flux out, I found. I mean, I don't know if it's causing thermal shock to the chip. I hope not. That'd be bad. But yeah, as it boils out, it pushes off all the flux, which helps. Because I find even after doing an IPA bath, if I don't get it really like all the trapped stuff out, I'll get like a crispy grey dried up residue, which is I guess like the reacted flux, but that's good enough for now. I guess next we might as well do the other STM32. There you go, STM32 C8. No, where did I put my C8s? Did I lay back up there as well, or did I leave them down here? That's a C8. Right, and let's say C8. Here's the other thing as well. Some people may already be aware of this, and it's not exactly a hidden secret. It's been quite well known for a while, but the C8 and the CB, for all intents and purposes, are the exact same chip. The on-paper specs of the C8 has, I think, 64 kilobits of RAM. Sorry, not RAM. 64 kilobits of flash, and the CB has 128. I might be getting my kilobits and bits mixed up or something, but yeah, I mean, generally speaking, yeah, the CB has more flash space, but like I said, they're essentially the same chip, and it's no real secret anymore that the C8s are just binned CBs. That being that they are off the same fab, all the flash is accessible, and the chances of getting a C8 where you can't program all the program all the flash into, is next to zero now. I don't think I've heard of anyone not being able to do it. It's no guarantee, but I've not heard of anyone not being able to do it, and I've certainly been able to do it for a while. So I saved some money and used the C8 chip. I've got some CBs just in case, but I use them to save the chip. Save the money where possible. And if it doesn't work, I could just swap it out. It's no biggie. But like I said, there's no reason to believe it's not going to work. All the others have worked absolutely fine. So let's get this on there. This is the main microprocessor for the tricorder. So the main program is all running on there. All the commands for the graphics are built up on here through the various scripts that I write, and yeah. This does it all. That's not straight. Come on. Close enough, I think. The problem is it's not center on the lens, so I think there's a little bit of like close enough, I guess. I'm putting on conspiracy hats, as I mentioned before. Chips are hard to come by these days, and these weren't easy to come by either. So, like, I only managed to get them on AliExpress. And while these are fine, there's been plenty of fake ones out there as well. I've been burnt several times trying to get hold of some, both before and after the chip shortage. Managed to get my money back most of the time, not every time though. AliExpress's protections aren't the best, especially when you're trying to explain what makes a fake chip. Because I don't understand half the time. The people on there aren't technically. They just see, oh, it looks the same as the picture. Or they don't understand what makes it a fake or counterfeit. Anyway, most of the time, I think I've only had one time when I've not been able to get my money back, which was annoying. It's still about 40 quid on the order, but are you going to come down? No. Let's get these ones slightly dragged off as well. I mean, I'm doing the drag solder on these as well. It's not really necessary. I might as well just wick them off, but I find it just leaves a cleaner looking solder job if I don't have to wick everything off. And it probably makes for a stronger bond as well. It's amazing when I watch videos of people doing this, and you can see them like effortlessly drag solder everything, and there's no leftovers on the chip. It's almost like everything is perfectly laid out. It never happens for me. Like I said, I think it's a mixture of cheap solders, cheap fluxes, and me being cheap, I guess. I mean, I have to be. I mean, I don't have a lot of money by any means. I'm still unemployed, which is never fun. So I have to save my money where possible, which is one of the main reasons why I buy most of my stuff from China. It's far cheaper than buying it locally usually. I do have an Amazon account, and it is convenient to have, especially when I need to buy resin quickly, because that seems to be the main place to buy resin at the moment. But the printer resin, that is. But yeah, especially for electronics and stuff and suppliers, most of the stuff does come from China for me because it's just the cheapest supply for it. Nearly all my resistors and capacitors are from there. I get a few odd ones that I can't find over there locally at the shops, usually like several times the price. If I have to, I buy from RS. I don't like to, but they exist for a reason. Usually it's to rip us off, but yeah. I don't think RS has ever been a cheap company. They've always been really expensive. And Farnell in the UK is nearly as bad as RS. They used to be better, but they're definitely a lot more expensive than they are in the States, I think. And yeah, DigiKey and Mouser, they are usually okay, but since Brexit, I think they're mostly. I think they've got warehouses in like Germany and whatnot, but yeah, since Brexit, that's made it a lot harder to order from them. I mean, I do still order from them. They can do it. It's not like it's impossible. It's not as cheap as it used to be. And ordering from Arrow's only good if you're buying loads of bulk stuff, because again, they're based in America and they're quite happily deliver here, and they've got good prices. But again, it's really only worth it if you're buying a big bulk order like 50, 60, 70 quid worth of stuff, which I don't do very regularly. Come on. Just want to just slightly realign you a little bit, not as good as I'd like. Come on. There you go. Again, good enough. I don't think I'll win any awards for that, but... again, maybe I'm doing it too soon, I don't know, but I just find, like I said, putting on IPI while it's still hot helps flush out the flux from between the pins. See? I mean, that's obviously now just spreading thin down flux everywhere. So clear. Again, yeah, good enough now. I'll clean off the rest of that residue later. What's next? Shall I do? I'm going to do that little TPS 61023. That's another awkward bloody chip to get hold of at the moment. The practically zero supply anywhere. Even from China. I mean, I managed to get some from China, but I ordered 3 times from different shops in China. 2 of them didn't even turn up. The third one did eventually turn up, which was great. It took ages to turn up, that one. I mean, far longer than I'm usually used to for China. But not only that, it's yeah, they cost about 4 times the normal price. Usually they go for about, I don't know, it's somewhere between 19 and 70p per chip. But yeah, I was spending like 2 quid, 3 quid per chip, and when I have to buy a bunch of them, I don't like ordering large orders from China. It is always a bit of a risky thing, and the money can end up just disappearing. But yeah, putting that kind of money into something that is potentially fake, 61023, it's a risk, and it's not fun. I try not to do too many stupid risks, so I don't gamble. Yeah, again, this is one of those awkward chips because it's actually hard to tell which one's pin 1. Let's just double check the file. Definitely is pin 1 on there. if I remember correctly, let's zoom in for this. It's a lovely smooth zooming action there. Let's just go up a little bit. If I remember correctly, that means that is pin 1. But let's have another look at easiest quick way rather than just looking it up online again. Just gonna have a look on the actual boards that I've already put on because they're all based on already doing it. Yeah, that's the line at the top. Means that's 1. Okay. Right. Making a right mess of this. Alright, let's get this little blob of solder on there. I'll say a little blob, that's a huge blob, but I'm not going to moan about that right now. No, wrong way around. Also losing this chip, that's not good. Give me it. Tiny problem with these bloody tweezers. They're old, they're bent. I've cleaned them so many times, but they still get sticky and covered in bits of flux, which make things awkward. That's a huge amount of solder. Let's just get that soldered on and I'll clean up in a second. Yeah, so this is the TPS 61023. I've mentioned this in my earlier tricorder video because this was actually one of the chips that I was trying to use to fix my power problems I was having on the previous version. And it didn't work for that. So you might be wondering why I'm using it here. Well, it's quite simple. I'm not powering the whole thing with it. This new version of the tricorder is running mainly on a 3-volt power system, but while the audio chip itself runs on 3 volts as well, the amplifier prefers 5 volts for the speakers. And I did some testing, and it's just noisier on 3 volts than it is on 5 volts. So I needed a cheeky, quick way to get 5 volts back on the board somewhere, and this ended up being it. Maybe again in the future I'll research other amplifier chips that are happy at 3 volts. I mean, that's the problem. Many say they're fine at 3 volts. That's just not the reality, though. Like this one says it's fine at 3 volts, but yeah, it's noisy. That one's on. Don't worry about that bridge in the middle there. They're connected anyway. There's yeah, I'm not too bothered by that. So yeah, that powers the audio which is pretty much this whole section. Zoom in. Sorry, focus, which is all pretty much this whole section here. So we got flash, which was one of the pre-assembled parts from JLC. I've got them to put that one on. I mean, almost all the passives on here, that's all done by JLC. I'm just focused on the main ICs because I was able to source them and JLC couldn't. So yeah, that's fine. So we got flash, that stores all the audio files which the JQ chip reads. That actually is also a USB device. So when I connect USB to the charger port, it actually has the data pins routed to this, and that allows me to access the folder which stores the MP3 files to be played back. So we've got the MP3 player chip there. We've got the amp here, and that then is connected. I was going to turn things around again, and routed to the speaker pins there. I was going to say, one of the other things I don't like about the JQ chip, regardless of what you name your files, even if you name them 1, 2, 3, 4, it indexes the files purely based on the order that they're stored on the chip. So you have to copy the files over in a very specific order for it to actually play correctly. So when you tell it to play file 1, it will play the first file that's been loaded into the flash, not the first file in a folder or in an order of numbers. It's really awkward as hell. I'd really wish they didn't do it that way, but that's one of the problems with this chip. So when I put the files on, I've got them ordered by number, but it makes it easy for me to just like select them in a certain order and then put them into the chip in that order. But yeah, that one's sorted. All right, with that one out of the way, let's get the SD card put on. Quite happy I found this particular SD card because it's fantastic. It's a low profile SD card, not the usual one you see everywhere else, but it's low profile and really small footprint as well, which means I can fit it on this board and take up very little space with it indeed. So you've seen like the usual ones you see in a lot of other embedded projects. They're huge. The one, you know, everyone uses them, I use them, and we'll be using them again in the future, but they're huge. They take up a lot of footprint. And as you know, with this tricorder, everything is small. There's not a lot of space in there. Oh, where did I put them? I literally saw them a few minutes ago. They're in this box of stuff, that's for sure. Alright, so these micro SD slots are low profile, not really designed for typical user access. I mean, I can imagine it's possible to design something to do them that, but they look like they're designed very much to have something on the board inside your chassis, not normally removed or taken out, or not normally for external access anyway. But yeah, they're really low profile, take up such a little space, and absolutely fantastic, and made by Molex. And because it's made by Molex, they're actually quite expensive. Or at least at least double the price. At least double the price, I should say, than the standard SD card slots that everyone uses and knows. That's, like I say, it's really good at doing the job at keeping a low profile and small footprint on this board, because there's not a lot of space on here. It's already quite a compact board. come on. Close enough, right? I mean, it was close enough before, but I don't like things. Now that I see it on the actual microscope, I can actually see when things are just a teensy bit out of alignment and triggers my OCD. Let's get that in there. Right. Yeah, what's next on this board? Let's get the big one out of the way. That's the wonderful FT810 chip. That's my graphics processor. A little bit of a drink there because my throat's starting to get sore from all the talking. Now, these chips have been a bit harder to come by, again, because of the chip shortage, but this one's more of a case of that Bridgetech, from what I understand, haven't been able to get the allocations that they're used to, so they've been having a chip shortage. But I've been in contact with Bridgetech on and off now for a few years because I did a bit of work for them. I won't say I did a bit of work for them. I did a project for them a few years ago, and because of that, I've been able to have an ear with a couple of their support staff who have been absolutely fantastic, and they were able to provide a small supply of chips so I can at least continue doing my projects for now, and hopefully in the future things will end up becoming much easier to get hold of. But yeah, these, I've only got, I don't know, was it 18 chips left? So fantastic getting hold of these chips, but yeah, still got to be a little bit careful. I don't want to waste them. So for instance, when I do phase 2 of the hardware monitor, I'm going to recycle the chip in it. I'm not going to just chuck another new chip. I use the one I currently have. I've just covered up the bloody pin 1 marker on that side. Yes, it is. Okay, now I know what that noise is. It's the it's my old camera. It's telling me it's actually just moving over to a new file, so it's partitioning off the files, it looks like. At least I hope it's what it's doing, or I'm not wasting loads of time not recording anything. Okay, so yeah, this is the graphics chip. This is basically the main part of the thing. Like, I mean, you got the main processor which runs the main program, but the graphics chip itself does all the LCD graphics, and it takes all the commands that I write in the scripts and the various functions inside the main program and turns that into imagery. So all the assets are currently stored on the SD card on this tricorder. Gets transferred over at runtime between page loads. Each page has its own asset file, and based on the commands I send, this renders it all out onto the display, which is fantastic. It's amazing you can do such a thing on a embedded device, really. You know, we're not dealing like with a big laptop or desktop type processor here at all. It's a 74 megahertz embedded RISC chip. It's not designed to render graphics at all, but this does it thanks to this chip. I mean, it's brilliant, but it is limited still. There are some limitations, and I've talked about it in my last video. It's limited by how many commands you can use per draw. There's limited RAM, so how many assets you can load. But compared to having nothing at all, it's amazing. From my understanding, they are bringing out they're working on the new chip that does actually double the command limit. I mean, it's certainly not going to be the same sort of price as this, I'm sure, but it's probably going to be overkill for most of my projects, but it'd be nice to play with one and see if I can come up with something that pushes it to its limits. Talking of pushing to its limits, so I did this project, like I said, for Bridge Tech a while back. I designed the hardware. I mean, the hardware is actually really very basic. We used just a blue pill and a display with the chip already built in. But I designed the chassis around it, really, is what I was getting at, and the button layout and whatnot, because it was a demo unit we were making for them, and I was working with somebody else based in America who actually made the game Arduino. He got in touch with me because of a project I was working on before, and they all liked it and wanted me on board, which was cool. It was 3 months of nice work. I mean, sadly, I wish it wasn't only 3 months. I wish it lasted years, but hey, never mind. The one very cool feature on it, which I didn't design or come up with, James did it. He managed to do a version or a fake on the Mode 7 from SNES, I think it was, to create a fake 3D plane effect. Because one of the things we were doing with the design, we wanted to create like a Tron grid style 3D rotation thing. I mean, the brief was make a futuristic looking dashboard for an electronic bike. We'll go onto an electronic bike, and the idea was just something to show off the chips, and it did the job. We did a good job with it. I believe everyone was very happy with it. The feedback was good. But he made this sort of like Mode 7 style grid effect, and where he was able to get this like 3D rotating grid. And I need to have a look at the code again. I want to have a look at the code to figure out how he did it, because at the time I didn't have a clue how he would have done something like that. But right now that I'm a bit more matured in my programming and skilled in my programming, I'd like to have another look at that code at some point and figure out exactly how he did it, because I still haven't got a clue. That's looking better. Yep. Where's the chip? There we go. That's all right. Yeah, that's good. It's a bit more clean, I think. But yeah, Mode 7 was a really cool little thing. The only downside to using the Mode 7, he said it took up a lot of the command line. Sorry, a lot of the command space, which is, I guess, this chip's only real downfall is the lack of commands. I mean, you can do a lot with 2048 commands per draw, but you run out. You do eventually run out. And I ran out when I was doing the hardware monitor, so yeah. Anyway, that chip's on there now. I think it's now time to move on to the power board, which is this center one here. I think before we do that, actually, let's have a quick talk about the rest of this board. You notice I have actually done a few bodge repairs. I'll quickly go over them, actually. So this one here is the SPI clock pin. For some reason, it wasn't connected on the trace. I'm not sure why I didn't do that, and I didn't catch it during checks. I've since become a lot more robust with my DCR checks. I definitely was it DRC? I definitely haven't been as good with them as I should have been in the past. And I probably would have caught this particular one. But yeah, that was missing. I've had to correct that. And here as well, I've had to fit into 10K pull-ups onto the I2C lines for the touch chip. That's the word. As well as 2 more on the back. I had to correct a USB data mistake where the data plus and data minus were the wrong polarity, so I had to switch them over there. And over here, I had to fit an inline 10K resistor on that pin there. Anyway, stupid little mistakes that would be corrected in the future. Oh, and one last one. The pins 2 and 3 of that Hall effect sensor were back to front, so I had to cut the tracer and hack that around. Anyway, they're fixed. They're not terrible, but pain in the ass to sort out. It took me a few days to get those changes done on all the boards, so yeah. Let's get these power pins sorted. Sorry, power chips sorted out. I believe I saw the chip a moment ago. That's one of them. That's the 24297. Let's put you there. And the what's the one? That's the TPS 6301. Again, I believe that's in this box. Okay. Let's get this 63021 done first. If I remember these correctly, I might have the back to front, but the 63021 is my main boost chip. Please do a good job for the camera. This takes the battery or input and puts out a steady 3-volt power rail for everything. I've never been a huge fan of doing DC to DC converters, but I've actually got into it a bit more in the last, I don't know, year or so. They've always been a bit of a magic art, but now I'm starting to get used to them. But I have to say, I'm not necessarily a TI fanboy, but their system makes it a lot easier to pick their chips for these type of things. They've got reference designs that are well documented. Their system for their power bench tools are good for finding the chip that suits the project. Let's do this one as well. And it's generally, I find it's a little bit more trustworthy than some random Chinese one that's on a popular module, which is what I've done in the past and has obviously caused me trouble in the past as well. Make sure that's the 24297. Yeah. So TI chips have worked quite well for me, and the reference designs are easy to follow and understand. Usually, some of the formulas can be a bit funky sometimes, but yeah. And this chip, if I remember correctly, this is, as long as I don't have these back to front, this is the charge controller chip, and this, let's zoom into them again to make sure I've got the pin 1 sorted right. Oh, where is pin 1? Pin 1 is... Oh, there it is. Okay. Right. I can see it's right there. Right there. Okay. This was recommended to me by somebody else who was working on I believe a smartphone, like a custom smartphone design. And apparently this chip is used in some smartphones as well. Really cool little chip. I'm not quite using it to its full extent, I think. I may be missing a couple of things, but I mean, for this, it's so far been quite good. But yeah, this chip offers a lot of protection. It's not... I'm trying to remember if it's... I'm pretty sure it's got overcurrent protection built into it. You can both program or set on the resistor things like how low you would let the battery go before you cut it off, so like under voltage protection and current protection as well. But you can do that both either by a resistor or by a software flag inside the chip, and it would choose the lowest of the two values. I wish it was possible to actually override that. That makes things a little bit easier, I guess. Might even be able to simplify design by just simply not having to have a resistor flag at all. Just go straight for the software settings. But it does allow... that does add a level of security and safety as well. So if you've not been able to get the program to running to program the chip correctly on like the last boot or something, it would then fall back onto the hardware configuration, which makes sense. I should point out as well, I much prefer QFN chips to... Is it QFP? Forgotten now. The pin variant. They just... Drag soldering these are so much easier. I mean, I say that it wasn't doing an amazing job with the capacitive touch switch. That was definitely been a bit of a pain. Let's have a quick clean up and look at that. Yeah, that could be better. Again, that could be better as well. And that could definitely be better. Wow, that's really bad. I'm wondering if I'm just running my soldering iron too cold or something. Because I'm trying to be a bit more careful and not overheating stuff. But I mean, my soldering iron's set to 300 and my hot air's set to like 250 or 260 at the moment. Is it this side? Oh, I can't remember now. I don't think that's bridging. I think they're actually connected, those two. Double check. That's better. Oh, that's sad, was it? Not very bright at all. Come on, let's do better than that. Yeah, I think so. My soldering's terrible, and my solder is also terrible. Never blame the tools, blame the artist. I'm very willing to be blamed. I could do better. Oh, I don't think that's. I think that's the solder pad lifting now. Yeah, those two pins are connected anyway, but that's the solder pad lifting. I think I'm gonna be careful. Let's put a little bit more flux and then just give it another little wipe. Yeah, that pad's now lifted. The solder mask, I mean, is lifted. I think I can get that cleaner than that. That's another thing I've got to be honest about. I've not been too impressed with JLCPCB solder masks. They're weak, but that may not be a problem in the future. I might be going to a different supplier soon for PCB design. Oh, let's do that one as well. Yeah, I just generally find JLC PCB solder masks, particularly on their black solder mask, which I use a lot, is it's just weak. It breaks and tears up really, really easily. It's not like I'm being rough with this, but I just find I can end up exposing traces really, really easily. I was like, that's not connected, is it? It's still not connected. Believe it or not, this actually went a lot smoother when I was doing the bulk of them. This is the first time my QFNs are actually really struggling to solder properly. I mean, I knew there was going to be some, mistakes needing repairs and whatnot, but I really thought this was going to be easier than this. Hey, that looks better. I can only put it down to do, recording nerves or something, I don't know. This one. Let's see if there's enough solder on that still. No, there isn't. Alright, it looks like it is connected, but it's not very well connected. I will go over that a bit more. Again, this is actually these pins are actually connected anyway, so if that's just solder mask coming up, I think. Let's see if the actual pin is connected on the mark. Yeah, that's better. Yeah, they're connected. Good. Let's find. Well, we're hour and a half into this so far, and I'm actually doing, believe it or not, this is actually doing okay for time. This is definitely, yeah, not brilliant, but I was half expecting this to take about 4 hours, so we're doing okay. Only, what, 2 more ICs to do, and a bunch of LEDs, and a couple of board-to-board connectors. Right, let's get on with this next IC. This is one of the 2 LED driver chips. And these guys I do have a bunch of. But they've also been quite hard to get hold of again as well. So I won't be making a huge amount of tricorders, that's for sure. There's not enough chips to go around. Let's try and find the opening to the cellophane, because it's impossible to find. Where is it? Is that it? Yeah. Okay. I've just got to be careful opening this so I don't end up just spilling the chips everywhere. I need 2 of these, so come on. You can get there. Am I still recording? Okay, it seems to be. I accidentally just pulled the my cord out of my headset. Anyway, right, yeah, these 2 chips are the LED drivers. These pretty much run almost, I should say, all the LEDs. Not quite every single one. I've got a couple of LEDs that are actually controlled by the microprocessor directly, which is not a great thing to do. It's fine. There's nothing really wrong with it. It's just you do it too much, you can end up putting too much load on the processor, and you don't want to do that. But you know, in this use case, it's fine. The only reason I've done that as well is because it's literally like I've only got a few LEDs that needed, extra LEDs that needed controlling. Where these chips, they're 24 channel LED drivers, and that's a lot. That's cool. But if you've got 24, or two sets of 24 being used, and you've got, let's say, 6 more LEDs that need running, why use another 24 channel chip? Especially, again, these chips are kind of starting to become quite hard to come by and cost a little bit of money. They've gone up in price as well. I mean, everything's gone up in price. It's not just petrol. But yeah, these chips are really great to use, actually. I highly recommend them if you can get hold of them. You could get a lot of LEDs running on these quite happily, and really easy to program as well. I mean, it's just another addressable chip. They kind of run like shift registers as well, like many of the others, but they're simpler, I think is the right way to describe them. I mean, all you need is a resistor to set the constant current, and they run PWM, very high speed PWM. I can't remember the exact number, but far higher than the PWM of the microprocessor. And yeah, a resistor, capacitor, power, and you just connect your LEDs to it and feed in data. And yeah, they run that data, and they're incredibly fast. I mean, they're probably not fast enough to really run, let's say, a big LED wall or anything like that. You know, they're far more dedicated chips for stuff like that. But for stuff like what I'm doing here is absolutely brilliant. I prefer these to trying to use a load of was it WS2811 chips. I mean, this is, to be honest, this is probably cheaper to run like this anyway. But the yeah, they're good. Again, that looked like it went on well, but I'm not convinced. I'm going to have another look, because today my soldering has not been as successful as I'd like it to be. Come on. Maybe I need to retin this again. I've been retinning this one a few times lately, and I'm wondering, I mean, it smells like it's got a bit of hydrochloric acid. It gives off that sort of smell. So I'm wondering, I don't know for certain. I think the tinning stuff has a bit of an acid inside it that etches into the metal and allows the new tin to bond with, I don't know if bonded is the right word, but lay on top of the newly exposed non-corroded metal. And yeah, that's what it smells like. And I've been doing it quite a lot lately, and I do wonder if it's already maybe prematurely eaten up that tip. I only swapped it out last week while I was working on these current boards. Let's get this gunk off and have a look. Okay, I think that's going to go in the bin. That looks good. Yep, that's good. Yep. I think that one's good. It's done it again. Not so good. Yeah. Okay, so it's just that bottom edge. Oh, where are you? There you go. And that was my stomach. I could do with some lunch. I mean, it's 6:30, so I could definitely do with some lunch. What I'm going to do, I'm going to get this finished. There's not a huge amount left to do, and then I'm going to go and have my supper. But yeah, I think that's soldered okay. Those last 2 pins could do a little bit better. Oh, that's better. Okay, that's those two done. Fresh contact. Right. I think that's cleaned up enough for now. What else do we need to do? I'll tell you what, let's get this. Actually, no, we'll do these 3 resistors first, and then we'll do the board-to-board connectors. Right. Yep, that's it. Right, so these 3 resistors, they're the essentially, as I was mentioning before, with the various power chips, they're the essentially the hardware-based programmers for the I believe it's just for the battery control chip. Those are the words. Let's remember that. Like I said, I do actually have a bit of a stutter. The way it usually shows itself is by the fact that I just sometimes completely forget the word I'm actually trying to say, like mid-sentence. Even though I know what the word is, but getting it out is just difficult. Anyway, I'm in a mess of that one. Let's see if we can do a bit better here. I won't lie, I actually am getting a little bit hungry. But not too hungry to work. Alright, what I am going to do, I'm going to get these resistors done. I get that one board connector done. And then I'm probably going to go for supper. And I'll come back all refreshed and I get all the LEDs done because they're going to be a bit of a job. They take a while. There's quite a few of them. I say all the LEDs, it's just the surface mount LEDs. I will be dealing with the through holes at a later date, usually around the time I construct everything, because I need to, particularly say with the front scanner, I use the actual printed model to put the LEDs in, so I know the lengths that they need to go, because they sit in the PCB at slightly different lengths. If I remember correctly, this is actually part of a voltage divider, and I believe that's to set the nope, can't remember. There's two here. We've got the voltage divider and then we've got the 230 ohm one on the other side, which I'm using a 232 ohm resistor. I'm hoping that those 2 extra ohms aren't a problem because I actually struggled to find a precise 230 ohm one. So one of them's either current limiting or charge or discharge limiting, and the ever so slightly off value, while may not be 100% accurate to what I was setting to, maybe it's not enough to cause a problem. We're talking like a % difference, really, probably. Hello, Future Me here, editing this video. I realised I actually totally messed up the description of what this voltage divider and the 230 resistor is, so I thought I'd just get it straight here. The voltage divider is actually part of the temperature sensing circuit for the battery safety, to make sure that the battery doesn't overheat, so very important. That's there. And the 230 is for the current limiting control. Again, that's part of the hardware set value for the current limit. Anyway, back to the video. I mean, in the sake of the 232, that's probably like less than 1% actually, but I mean, the inaccuracy of the resistor itself is more likely to be wider than the actual calculated value, so I'm not too worried. That really didn't go well, did it? Come on. Also, just to might as well mention, most of the passes on here are 0402s. So no, not 0402s, 0603s. I used 0402s on the other version, and they're just, I could do it, but it's just too much of a fiddly pain in the ass. I thought, why do that to myself now if I didn't have to? I had enough space now to use the the 0302s, so 0603s, so just use them. There's a little bit too much solder on there, but yeah, it's fine really. I'll just get that quick clean. That is a lot of solder on that. I'm not happy with that. Let's see if I can. Yeah, scraped off a bit. Reheat that so it sits a bit more flat. I mean, it was fine. It was electrically connected, but yeah, I've got a bit of an OCD with these things sometimes. Maybe stupid, but yeah, it's better. Yeah. All right, let's do the top side board-to-board connector next. Let's do that one. Now I'm going to take a break and eat. I've got pizza to do. I'm just going to put it in the oven. Nothing too special. Right. I guess this is another big one actually. Special component really. Board-to-board connectors between the main power board, which is what I just showed here, and this front cluster array. I needed a low profile connector. This has a mating height of 2 millimeters, which is perfect. It means that not only does the other components on the back of here fit underneath it, it's compact enough that I was able to fit this all together in part of the new front sensor assembly. Again, this is a Molex part. Really fantastic. This helped. And also, again, not exactly cheap. I mean, they're not. It's not that they really break the bank or anything, but they're not cheap. I think they're about 50, something like 50, 60, 70p each or something. And there are probably like cheaper suppliers, but this is like having to buy from, I think, DigiKey, because the only ones were supplying it in the area or something. Well, actually, these are Mouser, I think. Oh, who knows? I can't tell from the packaging. Let's get this on. Trying to get this perfectly centered. I mean, because of the problem is I've got my design is got quite tight tolerances, so getting this as perfectly centered as possible is somewhat crucial, I guess. It's definitely a bit off as well, because it's all got to mount together on the front and fit into a space. Alright. Let's have another go at drag soldering this lot. Might need a little bit of wicking. Cool. I'm happy with that. Yeah, that's fine. Excellent. Let's just clean that off. Brilliant. I think that is good enough there. That's pretty... Oh, it's maybe not quite as centered as I want. Looks like a bit more on that side than there is on that side of the pad. Let's just quickly just recenter this again, and then I'm going to have supper. I might... think that's probably going to be as good as I can get it. At least while I'm this hungry, anyway. Yeah, I'm happy with that. Oop, let's not knock the camera again. Right, we are 2 hours into this recording. Obviously, I'm hoping it won't be 2 hours for you. I'm probably going to edit a few bits and speed up a few bits. It's still maybe at least an hour, maybe even an hour and a half. But I'll try and save you some of that time. But I am going to take this moment to go and have a break and have some pizza, come back in about half an hour, and get on with work. After this, we'll be doing the reverse-mounted LEDs on the back here. And then after that, there's a few front-mounted LEDs to sort out on this side. I suspect it's going to take another hour at least to complete this, so hopefully you're enjoying these long videos, and for myself, I'll be back in a bit. For you, it'll be about a few seconds. See you shortly. Oh, hello everyone, I am back. I just had a lovely pizza, and I'm probably going to lose a few subscribers to this, but yes, I put pineapple on my pizza. Anyway, back to work. So where did we leave off? I just finished the board-to-board connector on this side. There is another one to do, but we'll do that in a bit. And I wanted to get on with the LEDs. These are the reverse-mounted LEDs I've got. I had to create an extra footprint for this. I got the feeling that I might have actually originally designed these with 0804s in mind, but I've only got 0603s on this one, so yeah, we're going to go with that. Let's turn everything back on. Right. Let's start getting these, some solder on these. I've also got a tea. Just finished off a picnic bar for pudding, and it's a good time to get back to work. I want to get this done very soon. I've got a fair bit of stuff to get on with as well. As always, I do apologise for the rambling. I do apologise for all the rambling, but yeah, this definitely is proving to be a lot of work, and I don't really know what to talk about half the time. So these are the LEDs. 1, 2, 3. Was it 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. And these ones sit behind the what I call the mini screen that's in the door. Because of the new design I'm doing, I wanted to make the thing to be quite low profile. So in order to fix that, the reason why for this is actually mostly because of the touch sensors, but to make this work as a low profile thing, I had to create a think of a way to embed these LEDs on the backside of the PCB so that they don't protrude over the front of the PCB itself. The reason was because originally one of the ideas was to put the decals directly onto the PCB's front side. That's not strictly happening anymore, but the idea behind it is to it's that way around. Okay. The idea behind it is still be low profile enough that I can have all the capacitive touch pads closely mounted and flush to the chassis. I just had to quickly double check the polarity of these LEDs because they're small and the markings aren't exactly easy to follow. Not to mention the fact that some of these LEDs have the same markings, but the polarity is still reversed compared to each other, so that's really useful. So on these ones, it's this way round. I might have to double check something on a few of the other builds just to be sure. But yeah, this one, come on, sit correctly, will you? The vertical line there is the negative side, but I've seen it where that's the positive side, so we hopefully shouldn't have too many troubles with this though. Like I said, I think I designed the actual footprint with the large ones in mind, but I don't actually have any, so having to use these small ones makes no difference in the end once they're soldered on. But soldering on can be a little bit awkward. It doesn't always capture the solder mask. Solder paste. Okay, so that's the white LEDs. Now I need a green and a yellow. Green. And I need to also double check the polarity on this one as well. It's the same with the white ones. And now a yellow. Now I am 99.999% certain this is also the same polarity as the green one, because I believe I was using these ones when I was doing all the others. So we've done a little look. Oh, that's unfortunate. I might have to spin those round, because I just noticed that they might be back to front on those ones. I wonder what happened there. Odd. They're not working either way. When I do the LED test on the boards later, I would have to double check that. I've got a feeling I may have to spin those ones around. But for the moment, actually, let's just double check. I have actually got this the right polarity, haven't I? On my... Okay, so yeah, negative is on that side. How odd. Oh, unless... Is it? Uncertain. Oh, that's... Might have to correct those. Anyway, never mind. These ones are correct now. So let's have a quick sip of tea and we'll get on with doing this. The good chance is I'm going to need to put some extra solder paste on them because it probably isn't quite enough to bridge across the LED chiplets, but we'll do that in a moment. Let's get this melted. Definitely not quite enough there. Let's put some more on. Yeah, putting things in reverse, like mounting on the back, for instance, and through a hole is a nice little way of getting some low-profile stuff sorted out. I've also done it with the gel pack LEDs as well, and we will be doing them next, probably. But it keeps like a good way of having a low profile. That's definitely still needs some more. I think I have slightly set the stuff in the syringe. Oops. Sometimes lightly heating the syringe helps it flow a bit quicker and thinner out of the thing, but sometimes I make the mistake. Come on. Will you bridge over? That one bridges over. But the other one has been a pain. Try again, I guess. It's got to be enough now. There we go. Right, next one. There we go. Just trying to coax the solder onto the LED. Come on. Heat back up again, why are you? Let's try again. There you go. Now you went on pretty easily. And you. Okay, maybe not the prettiest job, but I think they'll do the job. That'd be okay. Like I said, next I'll be doing the gel pack LEDs, which are exactly the same sort of setup, really. Let's get some solder paste onto them. Form of white LEDs. 1, 2, 3, 4. Right, these ones are sync based, so yes. Right. Before, the LEDs have been driven directly off the microcontroller, with the microcontroller providing the power, not syncing it. Seems it doesn't really make any real difference, if I remember correctly. But these ones sync into the driver, so the common pin there is power. Come on. Need my little pointy scalpel. It's a bit blunt now, but I've been using it to help scrape the traces and whatnot, but it does as an extra little tool, just so I can try and see what I'm doing. Last one. Right. Alright, let's see if I can get all these. Oh, there we go. That's better. Oh, bollocks. There's back in. Now, what is also interesting about these footprints is that the actual copper comes up a little bit short from the drill hole, and I didn't design that. That was done by JLCPCB. Maybe they don't strictly like this type of design. I don't know. I mean, it's a little bit unconventional. I mean, it works. It's not the first time I've seen this happen, or used in even in a product. Let's just put a little bit extra on there. Good. That's those ones done. Let's put a little bit of... get some more IPA in there. And yeah, I mean, they need a bit more cleaning out and to get rid of some of those solder blobs, but yeah, so you can see how they get passed through. The light will just flash through there, and I'm going to have like a little diffuser on top of this just before it comes to the clear plastic for the gel pack itself. And yeah, ooh, that one definitely could do a bit more of a clean out on those ones. Right. I'll do this off camera quickly just because it needs to be off the plate to melt this. I'll give those again a proper little wash later. Right, I think what I should probably do next, as we're on the topic of reversed stuff, is this reversed button. This one's a little bit of a tricky one because putting in the button's fine, but you know, it's a push button. The trouble there is it's going to get pushed, which means there's actually a little bit of extra pressure. Come on, get out of the drawer, please. Stop being awkward. Oh, that's quite full. Right. So these are like standard push buttons. There's nothing really special about them. But the as you'll see, the idea again, because it needs to be low profile, because these PCBs have been mounted quite near the surface of the tricorder body. I'm placing them again in reverse. So I have a part that's milled up perfectly for the hole, and then the button is visible on this side. But like I said, the problem is because there's pressure, there's a danger that over time this could lift the solder pads. So what I've been doing is not only am I soldering these on, I'm adding an extra level of... Oh, that's come up a little bit. Let's push that back down again. I'm actually adding a little bit of super glue around the body of the switch. or the button. It's a little bit tricky though. Sometimes it works absolutely fine, but other times it's actually jammed up the button occasionally. So there's a bit of a few attempts might need to be made of this. We have to see. Just got to make sure I get rid of all that grease. Okay. Tissue and super glue at the ready. I'm just using some cheap old like multi-pack stuff here, but just be really careful. I'll let that soak in for a moment until I figure out where to put the lid. That's it. And wipe any excess off and hope that's only gone down into the sides. Oh, no, it does look like it's gone in the button, but that's not the end of the world just yet. I'll let that set for a minute and we'll figure out what we're going to do. Hopefully it doesn't set too bad in there and it's just a small amount. If it's a small amount, it'll be fine, but yeah, it's a bit of a gamble if it's going to be absolutely fine or not. What I might do as well, I've also got some UV resin glue as well, and I might also add that onto the back as well, just to give it a bit of extra reinforcement. But to see how things go in the short time while I'm been assembling these. Let's put these LEDs back because they're done. Right. It looks like it's working so far. Oh, actually, yeah, that liquid I can see in there might actually just be the IPA. But that looks like that's okay. So what we've got is a little bit of glue's gone down the sides, and I'm hoping that that's going to give a little bit of extra reinforcement to the pressure as it gets pushed down all the time. That's hopefully going to take up just some of the strain, rather than just putting it purely on those back pads. I can actually do it a little bit slightly less pointy. There we go. But yeah, I'll probably put a blob of this UV resin as well and see how, if that helps as well, and hopefully that should all be fine. Okay, but next then, let's do the... Are we complete on that side? Oh, we are. That's good. Okay. More LED work. I'm going to start off with these two ones up here. These are a bit more of an awkward one. Not that they're not physically awkward. I mean, that's not what I mean. The I think they're 6060. Sorry, LEDs. But the ones I got are not only are they reverse polarity, so this isn't pin 1, that is pin 1. They are also a different sequence, different order of LEDs. It's not RGB, it's something like GRB, or was it the other way around? I think I was using these ones. So it's not the end of the world. It's not the same as the very first tricorder. I realised this when I was putting together my first of the PCB of these and testing it, making some of the revisioned hardware. Sorry, the revisions to the software. The LED sequence was just wrong with it. It's easy enough to correct in code, but I have to also make sure I've reversed the actual LED, the polarity of it. I'm not really sure what happened there. I guess these LEDs come in multiple formats, and I just somehow didn't spot them when I was ordering them. I mean, it's okay. Like I said, it's just for the most part, I put them on back to front, and the corrector in software, which, okay, long term, that's probably not the best way to deal with things, but for these builds, it's okay. There's nothing wrong with that. Make sure I've got that back to front. Yeah. So where that would normally be pin 1, this is now pin 1 on this side. Let's see if I can fix the exposure. There we go, that's a bit better. So you can see there's the notch, which will normally be pin 1, but yeah, it's just reversed. And we'll put the other one on the other side, which you can't see on the microscope at the moment because it's easiest to do it in one go. There's a chance that might bridge. I did put a little bit too much solder on there, but we'll see. Oh, didn't bridge good. Yep. I'm just going to do this other one. It's not necessarily going to be off camera, it's just not going to be on the microscope. Let's get this quickly on. Excellent. That's on. I just finished that tea. Right, so we get this button and LED on. Like I said, the exposure on this thing isn't great. I can't really do an amazing job with it. I tried, but part of me kind of wants to find out what SSC this microscope's running on, and I don't know, almost make my own firmware, but that means having to do everything from scratch, and I just really cannot be asked right now. I've got too many other projects to get on with. And not to mention the fact that there may not even be a publicly available development library for this SSC anyway. I mean, there's also the other side of it where I could just put a completely different SSC in there. Oop, yep, that was the other camera. I think what it is, I think it's hitting, like every time it hits 4 gigabytes or a size limit or something, or a time limit, it just beeps to say it's creating a new file. I mean, I noticed that the display itself runs on standard 4-channel MIPI DSI, and the camera itself appears to be a MIPI CSI camera, so it's quite possible I might be able to even put something like a Pi, or maybe not a Raspberry Pi, because they run on 2-channel DSI, which is annoying. Pi 4s do have 4-channel apparently, but they only support 2-channel by software at the moment, from what I remember. And I might have to look at another cheap SoC that would do the job. I mean, if I did something like that, I wouldn't want to spend money on it. It's be silly to spend money. I would spend like nearly 100 quid on this thing already. Why spend more money just to get it a little bit better? I mean, it's doing absolutely fine for now, but I don't know, maybe in the future I might want to change some things. It's not perfect. It has issues, software bugs, and I'm stretching to try and get this drawer out of my parts bin. Come on. And I just pulled the cable out of my headset again. Let's get this on. If I remember correctly, this button and LED, this is the emergency button. So underneath the emergency button, there's a big red button. The LED lights it up, and this is the actual physical button for it. So I can turn that light down a bit, see if that makes any better. Try to turn it down, and then tries to compensate, and then blows out the noise. So this LED lights the backlight of the emergency red button, and that's the actual button that it physically touches and presses onto. And you've been annoying. I think that is about as close as that's going to get. I'm pressing that down so it makes sure it lays flat when it sets. And of course it does. Just as I lifted that, it's still stuck to the bloody thing, and just let's try that again, shall we? Good. Yeah, that'll do fine. I'll do for now. Okie dokie. Next, what shall we do? Alright, we've got those two LEDs down, that LED down. Let's do the up, down, left, right LEDs. Now here's where things get a little bit complicated again. These LEDs are slightly problematic. Again, because I'm not using an actual proper solder mask, scraper type thing, they have caused a few issues trying to get these things to lay properly flat. White LEDs. Let's see. Are they in here? Those do, I think. Yep, those will do. And I want a yellow LED, ideally a 05. Do I have any? I need to clean these tweezers again. So yes, these LEDs have been these are a bit of a problem. I mean, they're good for what they do, but they're sometimes a little bit too awkward. Not only do they want to really lay flat, they don't always, the actual pads on them don't always stick to the solder itself. But they make nice little bar light, but they're awkward. And the other problem with them is the fact that they're plastic. They're not like a normal ceramic or anything that many components use. They're like a little thermal plastic package. So I have to use a fairly low heat on these, or I risk literally melting the LEDs while I'm trying to solder them. They're just really annoying, and I have melted them in the past. I haven't so much done it while working on the current lot of tricorders, but it has happened in the past. They're just annoying. Right. Let's see if we can do this without destroying everything. Ah, come on, that's just not fair. That's the other little problem with these. They've probably got too much solder on them, which makes them want to rise up, and I don't want these to rise up. Right. I think that might be okay. Oh, not that one though. Right, not pretty again. I'm not happy about that, but functionally okay. Let's test them. Now, if I remember correctly, this way around? No, other way around. Oh, I'm in the wrong mode. Sometimes using it in diode mode does make them lighter, but sometimes not. I wonder why. It's a bit of an enigma with this new multimeter. Sometimes it would work, and sometimes it wouldn't. I'm not really sure. Oh, no idea. Can't remember if that worked or not on the other ones. I've got a feeling sometimes when they actually are soldered on and they're connected to an actual thing, somewhere to sync to, they don't always signal correctly. Or at least they don't always seem to light up, and I'm not really sure what that is. I won't lie. But yeah, I do apologise as well. I'm rambling again, and the trouble is we're coming towards the end, and I don't really know what to talk about. We're nearly done. A few more LEDs. So these ones were the up-down, what I call the up-down, left-right LEDs. There's like a little array of almost like an up-down, left-right bar. And these ones run note. Okay, let's have a look at these ones. The one LEDs you're not going to get to see me put on, actually, which I just remembered, because they're actually on another board that I've yet to sort out, but I'm going to do them a little bit differently. I'm going to put them in my... I'm going to assemble them and put them in my reflow oven. But the actual, what I call the library LEDs, they're the full little chaser LEDs that run next to the screen. They're on a separate board. I've got them on a very thin PCB, and I will be doing them separately for now, at least. So what I'm not actually going to say what the plan is at the moment with these tricorders. So I'm selling these ones, obviously. I need to somehow get some sort of, I don't know, something off these things. It's been a lot of work, and obviously the people have wanted a few. I mean, I'd love to be able to sell these en masse. I mean, I wouldn't want to build them en masse, but I'd love to be able to sell them en masse. That is wrong colours. So I'm selling, these ones are going off, and I am keeping one set for myself. And then I'm pretty much done with tricorders for a while, I think. I don't want to be I don't want to just be building tricorders. I've got other things I want to be getting on with. I've got several big projects I want to do. Some of we've already sort of discussed in the past. One very big one, roughly 50 centimeters in a cube shape. That's going to be a heck of a lot of work, but I really want to get it going. It's been on the back burner for far too long, so that has to get made. No, those are red ones. I can use you up as well. So yeah, there's a 50 centimeter cube that I want to put together. I imagine you know what I'm talking about by now. There is a smart dial, haptic feedback knob thing based on another popular project that somebody's made, but I want to make essentially a Nest clone, a Nest dial clone, but one that doesn't require you to be like logged into a cloud service, and it will all be, running on your local network. And you can probably, there might even be possible to set up a local server that you can securely connect to and have that, remotely control your thermostat central heating away from home if you really want to. But it's only optional. You're not forced to use it, and you're certainly not forced to have anyone, sniff your data for it. I mean, Google doesn't need to know when you turn your central heating on, do they? I mean, it'd be a bit odd if they have to. Right, these are a couple of red ones I need. And it would be nice if they would come out of their... There you go. Oh yeah, projects, what am I working on? So there's a 50cm cube. There's a Nest-like thermostat I want to make. There is an RGB studio light I've been working on. That'd be a 32, no, not 32, sorry, 29, was it 28? Yeah, 28 watt studio box light, battery powered, rechargeable thing. That was actually, the PCBs for that was on the big bulk order that I made a while back. I still want to make a new speedometer system, but the plans for that have kind of gone a little bit odd, because I want the scope has massively increased to what I want to do. Originally I was going to make another speedometer based on the same technology as the Tricorder, so using the same graphics chip and all that, but I kind of really want to now have incorporated things like satellite navigation and whatnot, all built into the dashboard. And I've been learning a bit about that, actually. It is possible. I can get hold of a relatively decent, relatively cheap SoC system. Probably, I'm considering maybe a rock chip system. Maybe, was it 3355, or possibly even the newer, is it 3599 or 3588, whatever it's called. It's quite a powerful little chip, and it's but I think that the other one probably is more than enough, powerful enough for what I want to do. But yeah, I've been learning about an API called Mapbox, which is an alternative to Google, and you can custom design your own map style, and it has a whole list of different rendering engines it can use. Unity being one of them. It's kind of hard to find the information on it, but it apparently does support Unreal as well. And I'm thinking I might end up making the whole speedometer interface in Android and Unreal Engine. So Android being the operating system and Unreal being the launcher for it. Essentially a launcher made in Unreal. So you can still load apps into it to a certain degree, I imagine. But it would be all rendered inside the Unreal Engine, and it would be, the user interface would be built around the Unreal Engine, so all the visuals, the speedometer, graphics, widgets and whatnot, those will all be running on the the engine, and they'll probably have like an internal window for things like the mapping system. I don't know whether it's a case of having like an embedded browser, or if the whole system runs on. Oh, that's wrong. What have I done there? Blue, green, green. Those should be red. Why are they blue? Did I just put two blue? I did just put two. Oh. Let's correct that then. So yeah, those two are blue. They should be red. Have to remove them. So yes, I don't know whether if it's essentially running like an HTML5 browser inside Unreal, or if there is like a dedicated Unreal Engine based model and texturing system that combines into the whole, the mapping API. That's the thing. It's still, we're a long way down. I imagine I'll probably be doing something like this next year at the very earliest. Yeah, it'd be nice to play with and making it go further. I'm also planning on buying a nicer, newer bike, which I'll probably end up putting the system onto coming in the future. What else? I do have plenty of other projects back in my mind, and they all seem to have just disappeared the moment I started talking about them. I have a list somewhere. I can't remember where I put it though. It's probably on my computer. Let's take these off. Come on. Get off the bloody tweezers. Good. Let's see if that's going to be red. Yep. Yep. Red. Red. Right. I'll put that away just in case I accidentally use it again. I need 3 more greens. And 2 more reds. So okay, let's do 3 greens and 1 red first. We are so close to being done now. So these are the 3 LEDs, or sorry, the 4 LEDs that run at the top, just above the power button on the actual very top of the tricorder. Oh, come on. Oh yeah, that's right. Okay. So the few things I want to get done. I'm actually going to be building a CNC machine some point in the very near future, or at least starting to build one, that is. I'm going to be buying the parts at the end of the year probably, and the reason why was a few things. One, I really want to fix my rod core got railed 3D printer. I made it a while back and I haven't been able to use it as much as I wanted to because it's got issues. Things like the Z screws binding and it being a little bit unsquare, and it's not been easy to fix. And the problem is, one of the fixes I need to do requires some more milled parts, and rather than spend money getting somebody else to do them again, I've been kind of wanting one for a while anyway. Why not just mill them myself? Build a CNC machine and build them and mill the bits I need myself. And that actually opens up a few more ideas for me. So I'm going to be also be making a fully custom new mechanical keyboard. Oh yeah, I know it's nothing new. Everyone's done one, but yeah, I'm going to be milling the aluminium chassis, and I'm also going to be making a couple for some friends as well. One of my friends who is a Twitch streamer, he's going to be getting one that's going to have some Twitch related additions done to it. So probably some special hotkeys for running Twitch. I think it's called OBD. I can't remember now. Let's let that cool off while that's still there. So I thought that'd be nice for him. Making myself a new mechanical as well. And not to mention the whole like 50 centimeter cube thing I want to make. Many of the parts could probably end up being milled as well, which will help. I'll be laser cutting some parts, milling some, and I may have to do some electro etching for some other parts of it as well. I'm still kind of figuring all that out on the back of my head. This one's going to be a bit awkward. But also, it opens up some ideas for a few other things I want to do, you know, using the mill or using a CNC machine. It's not strictly a mill, it's... I'm trying to remember now. Is it a V2? That's right. It's technically speaking a V2 because it's like a tabletop thing rather than a big pillar mill. But it's capable of also doing block cutting. It's not simply for sheet cutting. It can do blocks, and I've kind of been thinking about going back to an old project that I know people have been asking me to get back to, the Play Dog, and making a CM4 version of it. Or I'm not really sure I want to do a CM4 version anymore, to be honest with you. I was planning to. That was always the plan, to go and do a CM4 version. But after you know, loads of people have already done CM4 based, you know, retro playing machines, and I'm starting to wonder whether I should really, you know, should I just be another one of the, you know, one for people to see, and I may not even be able to, you know, mass produce enough, or at least make enough to sell. So I have to consider that. But what if I didn't use CM4? What if I used, again, the new RK Was it 3588 or 3599, whatever it's called? That might be a better option, but there's another maker who has done an absolutely fantastic, I would say, somewhat like a Switch style emulator. A guy called Stone Edge, absolutely fantastic. If you're in retro stuff, you probably know about his stuff already. He had some of his cases milled in aluminium, and they looked brilliant. And it got me thinking about my one. It wouldn't take too much to refine the design enough to consider having it milled, or consider milling it myself. And I mean, that's something I might consider actually doing. But again, it's way too early for stuff like that to say what I'm actually doing there. I don't know for sure. Right, okay, that one works. Let's just double check these ones, but I need to break this trace. It doesn't matter, it's a dummy trace anyway, I'm not bothered by it. Red. Oh. Okay, it's the common side, that's that, and green. Good. Though my OCD needs to tell me that I've got to slightly correct that one. Just quickly straighten you up. Right, so close to being done now. 2 bits left. Right. Right, we have... I had you nearby. Where did I put you? Is that right? Yep, that's one of them. Right. Okay, so these 2 parts. This big one I'm about to put on now is actually the other side, or the other half of the board-to-board connector, the one that has a 2mm mating height, which is very important because I've designed it so these 2 PCBs can be 2mm apart. And then this ribbon cable next to it. So the board-to-board connector passes all the information from the front power PCB to the main front LEDs. That's just that main one PCB and all the LEDs there. That's mostly the data and a few of the actual LED signals themselves, because there's more than 24 LEDs used there. Ooh. I heard some multiple noises then. Oh, everything's still running. Right. Okay. I swear, when I was actually making these for all the other boards, this went a lot cleaner. I think it's just, like I said, the curse of recording. Okay, yeah, so the board-to-board connector passes several of the LEDs and the data to the front LED driver, and of course power for those. And this ribbon cable passes to the board that connects between the board that holds the gel pack and the power button. So on here there's data, gel pack, power button, and some LED signals as well. On that gel pack button there's another ribbon cable which isn't going to get an actual connector, it's going to be soldered on, that passes to another cable that runs to the absolute top, which includes the little LEDs at the top, like I said before, and the what I call the Voyager emblem LED. That's the sort of like the eye-shaped thing at the very, very top. It's seen on a few of the other props, but they usually use like a jewel or a hologram graphic sticker in there. But I put an LED in there for this design. Definitely be a little bit up. There we go. Oh, that's okay or no? Yeah, I think that's better. Right, let's get this. Yes. Oh, that's very wonky. Burn my hand while I'm doing this. Trying to line everything up as best as I can. Right, looks good. I mean, it looks straight at least. It doesn't look like it's all over the place. Okay, let's get some solder on there. Flux on there, and then actually it's easier, to be honest, to do this from the other side. Time to wick that away. Right, that's looking good. I mean, don't worry about these ones down here. I mean, I'll do them anyway, but they're actually connected anyway. They're not, it's not strictly bridging. double check that one because I couldn't see very clearly. That looks good. Definitely double check it's also centered. Yeah, I think that's good. Alright, I'll just clean this off and that is it. The board is soldered, mostly, kind of, sort of. Alright, like I said, this is all just the SMD surface mount stuff. There are still some LEDs I've got to put on. Those would be through-hole ones, and most of them are going to be installed as I'm putting them the actual tricorders together, because I need to, know the exact distance from the boards they are. And I mean, sure, I can. It's all in the design files, but it makes no difference. It's easier just to sit them in their space and put the LEDs in and then solder them into their slots. And that's it. That board's done. Right, there is this, that's a connector that connects to there. Again, that is like a header pin connector, a right-angled header pin connector, which I would be putting in at installation time. The LEDs go here. They're actually RGB LEDs, but with the blue pin snipped off. And oh, curious, I just noticed that the silk screen's missing on that one. These get snapped off and then that gets placed on top and soldered. Same for that. There's another RGB LED that goes there, and there's another RGB LED here that goes there, but again with the blue snipped off. And of course the battery that goes there. I mean, that's pretty much it for now. I'm going to be doing an assembly video at some point in the next few months for the tricorder, where I'll be installing the actual PCBs into the chassis. I hope you like this video. It is rambling. It's very long, but I hope you liked it. And if you want to see more content like this, where I'm putting PCBs together, do let me know, because I've got several PCBs that need to be done, and I'm going to be quite happy to go through them rather than just recording B-roll for a big block video. I actually do enjoy doing a video like this if this is what people like to see. If you like what I do, please consider subscribing, and if you like this new format, let me know in the comments. As well, if you want to help support me and my project, you can do so through Patreon and GoFundMe. Links are in the description below. Again, thank you for sticking through this very long video. Stay safe, take care, and goodbye.